Welcome students in the series of angle of friction. Now this topic we have taken from the chapter laws of motion. Let's begin. The first topic is angle of friction. From this diagram, we can easily understand few basic things like this is a box. It's completely stable, means static position. Static in position. For static position, normal is balanced by weight. So mg is nothing but a factor which we are calling as weight. Now here we can see there is some pattern and phi is something. So what is angle of friction? The angle made by the resultant of the normal reaction and limiting friction with the normal reaction is called basically angle of friction. Means it is defined in the context of motion on the inclined plane. It is defined in the context of motion on inclined plane. Inclined plane means it is defined the parameters of motion. Parameter of motion on an inclined plane, like how much the particle is, how much the box is or system is deviated. The minimum angle of incline, as you can see, the minimum angle of incline for which body plays on it just start to slide. So the minimum angle of motion, okay, the minimum angle of motion, or we can say incline for which a body placed on it just starts sliding without any external force is called the angle of friction. In a one line, we can say the minimum force required. It is a minimum angle, okay? Minimum angle required to slide the body, okay? In a one line, we can generalize this. The minimum angle by which we can slide the body, okay? It is a condition and it will be an angle between in which the force and the normal. As you can see, this is a normal and this is the resultant force, okay? So force and normal, limiting friction with the normal reaction, okay? So normal with the limiting friction. Now here it is represented by phi, and phi is nothing but mu. Clear? So here phi is nothing but tan theta, or we can say mu. So suppose a block of mass capital M, it is placed on a rough surface, the body experiencing the limiting frictional force. Under the action is applied F. Let N be the normal of reaction acting on the block and R be the resultant normal reaction, okay, and frictional force. So in the figure, as you can see, OA what represent? OA represent the normal. It is what? Normal. OB represent FL, limiting frictional force. limiting frictional force. Completing the parallelogram OACB. So OC gives the resultant and okay, it is the resultant and final this will be N. So in triangle OAC, we know perpendicular by base AC by OA is equals to OB by OA. So after putting the value FL by N, it gives the value of mu N. So tan phi is equals to mu N. Mu S, what is the S? S represent the sliding friction. Sliding friction. So phi is K in the form of tan inverse mu S. I hope it's completely clear to you all. Now, as from the earlier graph, we can see N is what? Normal. Mg is weight. R is resultant. Phi is angle of friction. FL is a limiting frictional. So it is a limiting frictional force. The greater of the angle of friction, greater is the value of coefficient of friction. Okay, from the earlier equation, you can also see these things. Now move on to some multiple choice question. The greater the dash, greater is the value of coefficient of friction. Angle of repose, critical angle, angle of friction. None of these. The correct answer for this question is angle of friction. Second, the angle of friction phi is equals to tan inverse mu k, tan inverse mu s, tan inverse mu r, sin inverse mu s. The correct answer for this question is tan inverse mu s. Motion on a body on a rough horizontal plane. So, motion of a body on a rough horizontal surface. For that, consider a rough horizontal surface. So, this surface is a completely rough surface we are assuming, on which a block of mass small m is placed. So, I just placed m mass block. Let force P, which is greater than limiting frictional force, is applied over here. P is what? External force. Okay. Here the kinetic friction, because the body start to moving, so the kinetic friction will act on the body. Let A be the acceleration of the body. Because of this force, we can say the kinetic friction occur, and because of that acceleration occur. So the net force acting on the body will be look like that. If N is the normal reaction from law of friction, so Fk is equals to mu Kn. N, which is balanced by mg, as I told you, N is equals to mg. So we can write as in the form of, in the place of N, we can write easily mg from equation 1. If acceleration produced is A, then the resultant force will be F is equals to P minus Fk, means F2 minus F1 resultant. This will be F2 is F external applied and Fk, which is occurred by the friction. Which friction? Kinetic friction. We know the formula of force. Resultant force, because of which acceleration acceleration occurs. So P is again external force and Fk is kinetic friction. So A is acceleration and it comes by P by M minus mu kg. This is the first equation. Using the first, distance moved in a given time t and the velocity acquired can be calculated in the help of kinetic equation of motion. Now motion of a body on a rough inclined plane is nothing but the plane which makes an angle theta with the horizontal is called as inclined plane. For example, I have just taken, this is an inclined plane, slant line there, this will be. This will be what? Slant line. Slant line. So if in this slant line, if I just placed a box like M mass, which is a makes the theta angle from the surface. So this kind of plane we are saying as an inclined plane. I hope the thing is clear. It's not very hard. Consider a body of mass m placed on that rough inclined plane. Means look like that. A mass body. When applied force act on the body, frictional force comes into play. Because of the roughness, if exceeds the limiting friction, then body ready to slide. So kinetic friction occurs. Kinetic friction occurs. As you can see here, all these situations, this is a box, rough surface, or we can say inclined plane. Inclined plane, F is frictional force. This will be weight component with cos theta. So weight have a two component. In horizontal we have with the theta we have a cos component, and perpendicular with the, or we can say perpendicular to the weight component will be, vertical component of weight will be mg sin theta. Theta is the angle between the normal and the friction. So weight acting vertically downward, it resolve into two components. Okay, the first component is normal to inclined plane and the next one is parallel to the inclined plane. So the parallel to the inclined plane will be mg sin theta. Okay, and perpendicular to the inclined plane will be mg cos theta. Now normal reaction, as I told you, N perpendicular to the plane, frictional force F is in the upward direction parallel to inclined plane. Now if the body is at rest, inclined plane, mg sin theta balanced by the static friction. Understood? So F is equals to mg sin theta that time, and normal is already balanced by mg cos theta. If the body is completely in the static situation or a balanced situation, means each force will be balanced by the weight component. Okay. There is a no resultant extra force came because of that bodies start to move. Means net external force will be zero. That's why we are saying the body is in the static situation. Moving ahead with the next topic, angle of repose. So angle of repose is defined as the angle of inclined plane which a body place just began to slide. Okay, this angle will be angle of repose. Earlier we have taken also that same. So angle of a repose does not depend on the mass of the object as well. Okay, it depends only the area of a contact, how much area of contact the surface actually making by that inclined plane. But it depends on the relative smoothness, okay, means nature of the surface. for which the given pair of surface, the angle of repose remains constant. Now let us consider a block of mass small m at rest on an inclined plane which makes an angle in limiting equilibrium alpha with the horizontal as shown in this diagram. So this is a box which placed in this inclined plane making the alpha angle, which we are saying angle of repose. N is balanced by the weight component mg cos theta and P is balanced by the weight component mg sin alpha. If the body will be static, N is equals to mg cos alpha and we can say P is equals to mg sin alpha. So mg is nothing but a weight vertically downward and normal reaction, and Fl force of limiting friction. Now the weight of the body resolve into two components as I told, mg cos alpha, mg sin alpha. Perpendicular to the inclined plane, mg cos alpha, and parallel to the inclined plane, mg sin alpha. So students, these two components basically responsible for like kinetic friction, rolling friction, static friction also. I hope you understand. So this is all much about for today's class. I hope you understand many things. Take care and thank you for watching this video.